Oh my God.
Hi and welcome. Nice to see you. I'm John or Yanis, and today I'm going to show you how to avoid costly design and construction mistakes using building information modeling. If possible, turn on your camera so we can engage a bit better. I will answer your questions at the end of the workshop, but you can add them anytime in the chat. And finally, be proactive. Since this is a workshop, there will be practical exercises, which I highly recommend you engage in, so you can get most out of this event. Okay, let's go. I'll start a bit with my background. And how I realized that BIM really helps getting better buildings and how it has helped many other owners as well. About 15 years ago, while studying civil engineering, I had the first opportunity to experiment with 3D building models and modeling tools. It was during my internship. And then when I started my first job at a large design company, I quickly realized that none of my colleagues were working in 3D and everything was done in 2D. But I had a challenge. I found it really hard to understand how a solution on a flat drawing would look like in a real life. So it was very difficult for me. And I figured that I might try to model that solution first in the 3D environment as it would look like in the real life. I would test it, visualize it, and then after when I'm satisfied with the solution, I would then create the drawings and other deliverables for the project. So over time, I started designing the entire projects in 3D, extracting quantities directly, and even automating parts of the process. I made fewer mistakes, I worked faster than my 2D colleagues, and most importantly, I freed up time for exploring, training, and learning more about this new called thing, BIM. At my workplace, I saw many opportunities to improve processes, but the pace of change was slow at that time, and I wanted more freedom to innovate. So 10 years ago, most digitalization efforts focused on buildings, not infrastructure. And in 2014, I founded my company, ITID. And since then, we have specialized in the building information modeling sphere and the services related to that. And over the past decade, I've been involved in more than 100 different projects across Europe, UAE, and even further. And what's surprising, though it's like 15 years have passed since I first discovered BIM, yet for many in the industry, in the construction industry, it's still something new. Alongside my work in my company on large-scale projects, I have always used BIM to test its value in practice on smaller projects as well. So, for example, renovating apartments, managing properties, and in 2021, I also designed and constructed my own house with BIM. This has helped me to understand what aspects of BIM provide real value even to small projects and what is completely unnecessary. I often see that the same thing happens in larger projects too. Money is wasted on requirements for things that nobody actually uses, and that has really little value. So, in general, I'm convinced that BIM is one of the keys to achieving better buildings and making fewer mistakes. And today I'll show you how. I'll answer you 3 questions. So, what exactly is BIM and how does it help? How to use BIM for your advantage, and how to get BIM for your project. So let's begin with what exactly is BIM. In a traditional 2D process, the main material used by the client to make important decisions, such as the layout, is the drawings, which are also later used in the construction. Drawings, they are an approximate idea of what the building might look like in reality, and they rely heavily on imagination, as you have to mentally visualize how everything will come together. That's why there is at least one major problem. In the 2D process, mistakes are always made. These are mistakes in the design solutions. Something wasn't fully thought through, and those issues end up affecting the entire life of the building. They are mistakes that make it impossible to build as planned. They are errors in quantities, which contractor then uses to charge extra from the clients, and many, many other. So these mistakes, they happen all the time in very small projects, in large ones, in new builds, and especially in existing buildings. So some mistakes, they are easy to fix, others are impossible to fix. So those mistakes, maybe you have to live with forever, like 20 years in the building, and you'll have this one mistake that really bothers you all this time. And no matter how hard you try in the 2D environment, it is impossible to completely eliminate errors. And as one contractor who builds villas in France recently told me, that they are trying to put together multiple 2D drawings to understand where to put these MEP networks, but that's basically an impossible challenge. So they just try to figure out that on site, and sometimes it comes up to very unpleasant compromises. Building information modeling process, it's a completely different way of creating a building, creating a project. You start by creating 3D models of the building virtually. And in comparison with the model that is used for animations or renders, BIM consists of objects that are found in real life, like windows, floors, lights, and so on. And that allows to use that information for different purposes. For example, viewing how everything fits together for analysis, testing, solution evaluation, finding errors, and much more. So basically, before you find out problems in real life, you can find them in your computer, which costs much, much less than on construction site. And after all that testing and changes in the 3D environment, you can easily extract the same old 2D drawings and quantities directly from the 3D model. But there is a huge difference. The 2D information has a direct link to the 3D model, meaning that if you, let's say, move a wall, the finishes table and also all the drawings will update automatically. That also hugely reduces the amount of errors. What BIM also allows is to increase the amount of information gradually. So you can make important decisions step by step multiple times. For example, start with the location. You can have a box, modeled box that's put on a site, and you can figure out whether that's a good location or a bad location. You can also use that box to simulate whether the sunlight shines inside the building nicely and many other things. You can then continue by figuring out the layout of the building. So you just draw the walls, you can move them around as many times as you like and figure out whether that's the layout you really want. But as the information progresses, the amount of information progresses, you can also analyze the models from various perspectives. So you can catch errors and achieve much better outcome. So the result is a building that is far more suitable for its users, with fewer problems and painful compromises during the construction and operation. If you want to implement BIM on your project, there are two strategies you can use. So first one, you can have the models created from the start. That basically means that the designers who create the design are capable of creating the models and then extracting all the necessary information from them. Another option or strategy is that you can model based on the 2D drawings, but later at some point during the project lifecycle. Either it's during design or at the end of design or early in construction. That's also a possibility. Of course, there is also a possibility to mix these approaches. So let's say an architect is comfortable in creating the models and the MEP designers are not. So you might find someone that helps the MEP designers to create the models. And then there's the possibility to join everything together and look for the mistakes and errors before the construction starts. The recommended approach usually is the first one, that you find the designers who can model first, but both of these strategies work, and I'll show you a few examples. So first one is a project, a sports center in Latvia. In this case, strategy one was used, where the whole design team was able to create their own models. but it was the first time for them to work in a really collaborative way. And what it meant was that there were sort of rules of when and how to create the models, and how to share them, and how to check them. The results were superb. Many issues were found and fixed early during the design phase. So coordination issues, as seen on the left image, were quite common during the design, and they were easily found either by walking through the models or doing some additional checks, but also some more complex issues like code validation problems, as seen on the right side, also were found before the construction started. So in the case on the right image, there is a ventilation input pipe and also a sewage exhaust pipe. And according to code, they are too close. They need to be at least 8 meters, but you measure like this and you have 2.8 meters. So that's a problem and in compliance with the local code. So this was a overall very successful project, which was finished in the desired time frame, and also during the construction, there weren't really any big issues. So let me show you strategy number 2. This is also a case study. It was an existing building, and the design was done completely in 2D. But the project manager on the client's side decided to make sure that no major problems are left inside the design. So he asked us to create the models. So the process is, as we took the drawings, we created the 3D models from them, analyzed if there is enough information in the 2D drawings to create the models, and then we combined and analyzed the models in the 3D environment again. So during this process, when you create models from 2D drawings, it's very easy to find mistakes that do not allow for successful creation of the models, but also they wouldn't allow for construction. So for example, you can see wrong measurements. The scale of the models usually is one to one, meaning that it looks like it's going, the scale is as it's going to be in real life. But if you try to model like this, and you can see the columns here are not actually 5.3 meters, but closer, it's very easy to find this. Same as applies to different disciplines. So on the bottom picture, there's elevation mark of foundation tops in architectural model, and the other one is from structural model. And it's very easy to see that they misalign. So this is one process. And then the second one is when you create the models, it's easy to combine them and look for additional mistakes, which are really hard to see in the 2D environment. So here, for example, you see that the MEP networks, they were routed basically through door. And it was found at the very late stages of the design, this issue. And when we showed that to the project manager, it meant changes in the layout. So the architects needed to move the door on the other wall. And so this location can be solved. But the most important thing is the result. So several critical errors were identified and resolved before the construction began. So thus avoiding the need for painful compromises during the building phase. How to use BIM yourself. Well, next I'm going to show you how to use BIM to get better projects. We are creating buildings for a purpose, for people, for equipment that serves people, or for both, as in the case of industrial facilities. These goals determine how BIM can be applied to achieve a better result. I've been fortunate to work on several very large international projects, for example, the development of a salmon farm in Brunei, and I observed one important thing. The outcomes are significantly better when the client is more involved in the process of using BIM. That means fewer changes during construction, greater confidence in the layouts and the solutions, and better usability of the building. What does it mean to use BIM? In BIM projects, a wide range of tools are typically used to create models, to view models, to run some analysis, checks, and so on. Using BIM means actively working with these digital models throughout the project lifecycle, not just creating them, but also reviewing, checking, making decisions based on them. And it's about involving the right people at the right time to ensure the design is understood, validated, and optimized before it's built. On the client side, using BIM means that as many stakeholders as possible open, view, analyze the models, and do so as often as possible. One of the most powerful BIM tools available to the client is the ability to view and walk through the buildings in 3D. And these tools are often free. And one such tool is Autodesk Viewer. And I will give you an opportunity to try yourself to walk through a building right now. There are many different tools you can use to perform this, but this one just works in the browser. So basically you can view a building in a browser, and you can also locate for mistakes. So I'm going to send you now a link, or I'll send you a link in the chat, just a second, so you can open the model. Let's see. And then I'll show you how the tool works. Chat, here it is. Yeah, here's the link. Really nice if you could write that the link works, everything's fine. And I'll open it as well. Okay. So try to open the link. If you have any errors or questions, don't hesitate to write in the chat. And I'll just slowly explain to you how the tool works. And then you can play also yourself with the model. So basically, there are the main functions are at the bottom side of the tool. So here are some functions that you can use to navigate the model, but usually it's done using the mouse. Either you can click the left button, hold it, and then you can rotate the model, orbit it, or you can use the mouse wheel to zoom in and out. And you can also use press the middle button of the mouse to pan the view. So most of the free tools to view the models allow functions like walking through the building, measuring, creating sections, and sometimes commenting the issues you find. So this tool also contains the tools of this first person view. So when you press this first person, usually you will have an instruction how to use it. Basically, you can use either the arrow buttons or the WASD buttons on your keyboard. And when you press and hold your left mouse button and use the keyboard buttons, you can start walking through the buildings. Sometimes useful to go first inside the building, because then it will activate the gravity and you're able to walk around the building a bit better, like this. Okay, got it. So this is how basically you can walk through a building in the 3D environment. This is a very simple but very, very powerful tool in the right hands. So if you are the client, you are the expert, you can look in the 3D environment and try to find different issues. So that's what I want you to also do is when you're using this, try to find some issues in this model, and if possible, maybe post them in the chat. So here, the other tool is the measure tool. It allows you to measure in 3D environment. It usually snaps to some edges, but you need to be careful because it's in the 3D environment, measuring is not so easy. Here, you can change the units Under here, say millimeters. Yep. And I can close it like this. So this is the measure tool. And finally, you can use also the section tool. So I'll close these ones. Section tool works like that. If you look from top to bottom, it will create a section plane. If I choose here the Z plane, it will cut also from top to bottom like this. And you can see that in the 3D environment, basically you can create section in any location. So you can view different areas. Here, these things, they are, let's see, we can turn them off. Show properties, it's a space object. See here in model browser. Yeah, let's turn them on, off. I can just do it, I suppose, one by one. You can, I know, maybe I can hear the rooms, this one. Oh, yeah, I turned it off. So I pressed the model browser and located the elements and just hit them. So like this, I can create a section easily in any location, zoom in, and then view the building like this. I can also create a section from another plane, say X plane, this, and also using the arrows, I can move the section box. So it's called the dynamic section. You can easily, again, look at different areas closer and from this section view and look at the solutions if you're happy with them or not. So this viewer, it's basically free, but when you register, you can also create some markups, like drawing on the screenshot, adding some comments as well. It's possible. So it's a very simple but very powerful tool to communicate the design in 3D environment. Maybe you have some questions about this tool or viewing the models in 3D environment. So you can you'll have the link and you'll be able to view the models as well later if you want them. But what I usually recommend in the process is just going through the building. What we did in the, let's say in the Brunei project, is that we had a meeting with 30 plus people from the whole world. We just simply walked through the building and through every room, and then the professionals there were sitting in this meeting and just looking at the walkthrough and commenting on the different issues they see, like technology issues, design issues, layout issues, etc., etc. And then all this information was gathered into a list of comments, which were then added to the responsible people for them to address those comments. Okay, let me get back to the presentation. So, hope you tried to walk in the 3D environment. I just wanted to point out that's only one way to use building information models out of hundreds of others. So there are possibilities to simulate the models, like lighting, energy efficiency, carbon footprint, etc., etc. You can use the models to create more realistic videos, visualizations, simulations, etc. you can also capture the information like extract information from the models, like the quantities or anything that you need for some calculations. But anyway, there needs to be a purpose. Why do you need this information? And it should serve this purpose, because you can easily ask for everything, but you will, of course, pay for that a lot. And most likely, you won't have the skill to use the information. I'll talk about it a bit later. So how to get BIM on your project. In this section, I'm going to talk about how to set up your project so that BIM actually works. So helps avoid mistakes, improves coordination, and stays on budget. So usually there are 3 steps you can take to have BIM on your project. It works for both strategies. Either the models are created by the designers or they're created from 2D drawings. So first one is defining goals and requirements and putting them in a brief. Second is getting a team to help achieve those goals. And then the third one is being proactive and use that available information for your benefit. So let me explain to you in a bit more detail. So one BIM, please. If you ask for BIM like this, neither the supplier will understand what exactly needs to be done or how it will be used, nor will you have the clarity on what you'll receive yourself. BIM is both a process defined by specific activities and a set of technologies used to achieve results. But ultimately, both, so the technology and the processes, they are driven by people who create and use that information. And yet, I still see in many projects in the design briefs that the client tries to define BIM requirements in just a few short sentences. So the result usually is misunderstandings, unmet goals, and basically a lot of wasted time. The other extreme is overly complex requirements, and this is also quite common. For example, asking for high geometric detail of the 3D elements rarely serves any purpose and drives the cost up. With either strategy, it's essential to work with a team that is motivated, knowledgeable, and actively involved. As discussed, the ideal scenario is to engage a team that can create and work with models from the start. However, with a well-organized process, it's also possible to successfully onboard those who are still adapting to this approach. For example, working with your favorite architect and an external helper like us when we develop the models during the design phase. You can have the best team and the best requirements, but if the whole team is not using the created information, there is a high likelihood of not achieving those goals. I recently spoke with one of our clients about a project that just finished, and one of the key successes they pointed out was that the project was completed almost exactly on the defined schedule, and it was within the defined budget. That's actually quite rare in construction industry. And they also pointed out that BIM definitely played a key role in achieving that. But there was one important thing that stood out, and stood out specifically from the client's side and this project side, was that the designer, the contractor, the client, and even the end users were all actively engaged in working with the models. They walked through the buildings virtually, like I showed you previously. They reviewed the solutions in 3D, they provided their input, and that level of involvement was a major factor in the project's success. If we talk about the recommended process, and when we work with our clients, we typically say that it's this 4-step process you should implement to ensure that you gain real value from BIM on your project. So it's researching, so research phase, writing clear requirements, finding the right team, using and verifying the information. Now let me explain to you each step in a bit more detail. So every client and every project is unique. And if someone claims that they can create a single standard that fits all projects and situations, that's simply not true. That's why we believe that an in-depth understanding is essential. This means researching the available information about the planned building, why it's being built, the deadlines that must be met, whether there are any specific requirements, etc., etc. At the research stage, by reviewing all that information about the project and then talking also to the client and the professionals that gonna be involved in the project and also gonna use that building, then we can understand what are the main goals, both for the building, but also for the possibility to use BIM to achieve those goals. Once the necessary information has been gathered, we move on to develop the so-called BIM requirements or employers' information requirements. It's basically a set of rules and principles for the whole team to follow to achieve the defined goals. They cannot be condensed into a single page, as they include a broad range of critical elements, such as the goals, the intended uses of the model, roles and responsibilities, both from on the client side, but also the supplier's side, project milestones, how information will be shared, communication procedures, technical requirements, and some additional project-specific needs. So these requirements, then when they're created, they usually are typically integrated into design brief and also into the contract. After defining the requirements, the next step is finding the right team to help you achieve your goals. This can be done through either a formal tendering process or a more informal selection approach. The key is not to create a complex bureaucratic procedure, but rather to ensure that the process helps you identify the team that best fits your needs and is capable of delivering real value. And the final, I suppose, the most important step is to make use of the information, of the models that are created. And as I explained earlier in my example, success comes from being involved. Not only walking through the models, but also analyzing and running more complex checks to find errors, such as clashes, which might result in additional construction costs. So when to start? If you're wondering when is the right time to start thinking about BIM on your project, for the first strategy, it's usually recommended to start about 5 months before the design tender. This allows sufficient time to define and align the requirements and prepare for the tender. For the second strategy, which means that the models are created from the drawings at some point, it's recommended that you, of course, do it as early as possible, but I mean, the latest would be very early in the construction phase. But the later you do it, the less possibilities to change something. So imagine the design is done, you model, you find out critical issues, and then you need to ask the designers to fix the design. What it usually means is that the design, or basically the construction, will be delayed. Maybe by a couple of weeks, but usually it's, if the issues are like critical, it will be maybe even months. So anyway, that said, we've had really successful projects using both approaches. So either designers modeling from the beginning or incorporating the modeling later during the design phase. There are also a few things to avoid, that you should avoid when you consider a BIM, implementing BIM on your project. So one thing to remember is BIM is not a miracle cure. I'm 100% sure it helps, and it can help definitely compared to a 2D process, but it will definitely not solve all the problems. It will not solve problems regarding lack of knowledge or motivation, and you still need experienced people, experienced engineers on the project. Also, I mentioned that overcomplicating things, if you are new to BIM, it's not a good way to start. If it's your first project, start with the basics. Ask for models, use them for walkthroughs, like you did. I showed you how to do it today, and have someone more experienced maybe to help you with some specific tools to perform clash detection. You should always ask also, if possible, to extract drawings from models and extract quantities. That brings and gives a huge value, and I'll show you an example a bit later. And finally, never rely fully on one party to achieve the result you want. So being involved yourself, so the client's team, some consultants, designer, contractor, everyone needs to be involved. So, and that's a precondition for success. So at the end of this workshop, I want to explain the costs of having BIM on your project and also not having it. So calculating the value of BIM benefits is not easy. BIM definitely requires investment, but the amount depends entirely on what you ask for. Even in my own private house project, I invested resources into implementing BIM because I knew clearly that it would bring real value. As for benefits, they can vary, but the most important ones are avoided mistakes that cost you additional in construction and better quality solutions, for example, layout. The former can, so the layouts can sometimes be quantified, sorry, the avoided mistakes, so the errors you find, it's sometimes possible to quantify and give a number to that, how much it would cost on the construction site or during the use of the building. But some things like if the building is comfortable for the users, the layout is comfortable, it's something you cannot really put a number to it. And, you know, how much would it cost that something, it's, you know, for 20 years every day, it's some sort of room spacing is not comfortable for you. You know, how do you calculate that? But let me try to give you also two examples. The first one is it's our state property holder called VNI. They had a pilot project some years ago. It was the first BIM pilot project, public BIM pilot project in Latvia. I was one of the lead coordinators on the supplier side. And this project became later a catalyst for the state property holder, which is the biggest public client in Latvia, incorporating BIM into basically every project after that. And like, here's a brief overview of what we accomplished. So in this case, it was a pilot project and it utilized the second strategy. So the design was completed and the client decided, let's model the 2D design into 3D and have a look what we find. So the result, okay, the investment was around 40K euros, so 40,000 euros. But from the client's own words that they later put inside the public press was that the use of BIM helped identify and resolve more than 200 issues early, saving around 7,000 work hours and preventing potential losses of approximately 140,000 euros. So that's an ROI of 250%. I suppose it's not a bad investment. And this was done, I remind you, at when the design already was finished. So not during the design phase, which could have resulted also in much better return on investment. The second example comes from my own home project. And here the design was done in 3D from the start, but also incorporated the strategy too, where from some designs I had the 2D solutions modeled in 3D. And also for private housing in Latvia, you do not need to have the MEP networks, internal MEP networks modeled or designed at all. So this was something also I communicate with other engineers, found solutions to create these models. And just a few examples of basically the issues that were found. So one of the big ones was that the structural engineer, they didn't know I suppose they didn't know at all that there would be ventilation pipes in the building. And when I showed them this picture that there are going to be like big pipes there going through a load-bearing wall, they realized that basically they need to redesign their solutions. That resulted in additional couple of weeks. Completely different structural frame was created to support a large opening. And imagine having this issue on site. You know, it probably would have painful compromises, either lowering the ceiling height or something else to actually do this. And of course, it would also have additional costs. One other example was installing the ventilation machine inside the building. So by looking at just creating a simple section, I looked at the box and realized it seems that the doors might be too small to fit in the machine. So I double checked, and I realized that to install actually the machine, you need bigger doors. So again, if this would be found out later during the construction when the device has arrived on site, well, it wouldn't be a good situation. These are just a couple of examples. There were misalignments between structural drawings and architecture. If the contractor would build from structural drawings, I would have a different shape, terrace, and many other things. But I suppose the main and most important thing is that I managed to stay within the budget, so the starting budget, and there weren't any major issues found during the construction. So of course, some small things, but big major issues, nothing. All of that was solved before the construction started. And that, of course, helped stay within the budget and also within a defined time frame. And that staying within a budget was happening during the COVID and also during the start of the war, when prices of construction materials were, going up and up. But I suppose the most important thing after 3 years of living in this house is that I can honestly say that it brings me joy, because the layout is amazing. The location of switches, sockets, everything is comfortable. I mean, and this, you cannot give a price tag to this, but the amount of work and we put in during the design, walking through the building, communicating with the architect, putting inside the furniture, thinking what would be the best locations of the furniture, the light switches, the sockets, and so on and so forth, really help to achieve that goal of having your dream house. So what are the costs of having BIM on your projects? Basically, it heavily depends on the size of the project, the type, the stage, and other factors also you should consider. You can take an approach to do it yourself. That means you need to invest some time to research different BIM requirements and standards. There are plenty, but usually they are huge. You also need to incorporate those requirements into the contracts and the brief for the designers, for example. And you need to navigate the risks of different errors, delays, and also overpaying for something either that you ask too much or, again, too little, which both are problematic cases in many of the projects we're involved. And if you work with us, then we usually guide you through the proven 4-step process I showed you. We provide you expert support and insights from over 100 projects we're involved, and the result comes to less risk of overpaying, more efficient use of the time and money, and better outcomes. Or basically, the outcome is more resources left for you either to have a better project or invest those resources for your next project. And of course, the most important thing, you are happy with the result. The third option, it's also an option, of course, is to do nothing. You can keep working the old way, deal with the same consequences as always. So the same problems on construction site, additional costs, and in the end, the result you're not happy with. So my final question to you is, are you ready for a better building with BIM? If yes, feel free to contact me to discuss your project and how exactly BIM can help. If you have any questions, feel free to ask in the chat. I'll be happy to